Hello and welcome back to the Cracking FAANG YouTube channel. Today we're solving 724, find pivot index. Given an array of integers, nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of the numbers strictly to the index's right. If the index is on the left edge of the array, then the left sum is 0 because there's no elements to the left, and this also applies to the right edge of the array. Return the leftmost pivot index, and if no such index exists, return -1. We're given an example here, 173656, and we're told that the pivot index is going to be this element here. Why is that? Well, what is the sum of the elements to the left of this index? Well, it's 1 plus 7 plus 3, so that's 11. And then what's the sum of 5 and 6? That's also 11. So since 11 equals 11, this is the index where they are equal. So we would just return 6. What about this one? We have 1, 2, and 3. Let's see. Well, it tells us that there's nothing that satisfies this. So what is the sum to the left of 1? It's 0. To the right of 1, it's going to be what? 5, right? So obviously that's not right. What about 2? The sum to the left of it is 1. The sum to the right is 3. And for 3, the sum to the left is 5. And the sum to the right is 0. So we can see at no point do we ever get a pivot index. So this problem is pretty straightforward. We basically just need to keep track of the sum to the left of a number and the sum to the right. Unfortunately, this actually will be less than optimal to calculate. So what we actually want to do is we want to calculate the global sum of our array by simply just taking the sum of our elements. So we're going to get the global sum. Now, what we can do is we're actually going to maintain, as we go from left to right, a left sum. And what we're going to do at each index, we're going to check a very simple operation. We're going to say, is the global sum minus 2 times the left sum, does this equal to the current number? And remember, if the global sum is the sum of all the numbers, left sum is the sum of all the numbers to the left of our current one. If our number is actually the pivot index, then left sum times 2 should be the same, right? It should be the same as the left and the right if this is the pivot index. So that means that the total sum minus the left and the right times 2, so we do 2 times the left sum. If this equals the number, then we have basically found the place where left equals right. So it's a bit of like a roundabout way to calculate it, but mathematically it works. So basically if these two are equal, then their sum minus the global sum will equal our current number. So if that's the case, then we simply just return the index of our number. Really straightforward. Let's now go to the code editor and type this up. Okay, let's write the code. Remember that the first thing we want to do is actually just get the global sum. So this will be just equal to calling sum on nums. Sum on nums. That's the global sum. Now what we want to do is, remember, we want to track the left sum. So obviously this is 0 because we haven't seen anything yet. And we're going to go index by index through our numbers and basically check that mathematical statement, which I told you. So we're going to say for I num enumerate nums, we're going to say if the global sum minus 2 times the current left sum actually equals our current number, then we return the index that we're at because we found our pivot index. Otherwise, we do left sum plus equals to the current number, and we keep going through our array. Either we will return I inside of this loop, or we will end the loop and we won't have returned anything, which means that there is no pivot index, and we simply return -1. Let's run this, make sure we didn't make any global sum. Of course. Global sum, and there we go, accepted, and this should be accepted as well. Okay, perfect. So, what is the time and space complexity? So, the time complexity here, let's just get rid of this. To calculate the global sum, whoops, that shouldn't be here. To calculate the global sum, we know that this is going to take big O of n because we have to go over our nums and sum them up. Then in the worst case, we'll have to iterate over the entirety of the array one more time. So this is also big O of n. So this is big O of 2n, but we know that asymptotically, this is just big O of n, where n is the number of nums in nums. Pretty straightforward. So for space complexity, because we calculated the global sum and we're doing this mathematical expression, we don't actually need to store any extra variables other than just what global sum is and left sum, but these are just numbers. We don't actually need to define a new data structure. So this is just a big O of 1 space complexity here. So that is how you solve find pivot index. Relatively straightforward question. I think coming up with this one is probably the crux of it, because this is the most optimal solution and probably what an interviewer will want to see. Using extra space probably isn't going to be allowed on this one, given that it's an easy. They do generally want the more optimal solution for these. Anyway, if you enjoyed the video and you learned something, why not leave it a like and a comment? Helps me out with the engagement. Subscribe to the channel if you want to see more content, and I will see you in the next one.